Darren. I am Tong Wai Yin. The topic which is assigned to me is continuous function. In this presentation, I would like to first give some brief background introduction about my topic. After this, I will discuss about an important theorem related to this topic, that is extreme value theorem. While discussing extreme value theorem, I will talk about the idea behind the proof of this theorem, as well as explaining why this theorem is important. And in the last section of my presentation, I will be talking about an example of how continuous function is used. Now, let's begin the presentation. Continuous function is a kind of function which is very common and useful in the world of mathematics. The definition of continuity of function is as given on the slide. Let D be a subset of real number that contains the point x0, and let f be a function defined on D, which says that the function f is continuous at x0 provided that whenever xn is a sequence of points in D that converge to x0, the sequence fxn converges to fx0, which says that f is a continuous function if it is continuous at every point of its domain D. Continuous function is a fundamental and important concept in many fields such as mathematics, physics, computer science, and economics. Continuous function is widely used in many areas as it contains certain nice property. For example, in mathematical analysis and calculus, many of the useful theorems rely on continuity of function, such as intermediate value theorem, fundamental theorem of calculus, and extreme value theorem, which I will be discussed later. Besides, in physics and engineering, many physical phenomena are modeled using continuous function. For instance, the motion of an object and the distribution of temperature in the material can be described using continuous function. Other than that, in probability or statistics, continuous probability distributions are described by probability density functions, which are continuous functions. These distributions are used to model random variables in various statistical analysis. On the other hand, in economics field, utility functions and demand functions are often assumed to be continuous. This assumption allows smooth analysis of consumer behavior and market equilibrium. In short, continuous function is really very useful and important as it is well applied in many real-life situations. Next, let's discuss on an important theorem which related to continuous function, that is extreme value theorem. The description of this theorem is as shown in the slide. Let D be a closed and bounded subset of real number. If f is a continuous function defined on D, then f has a maximum value and a minimum value. Now, let's discuss the idea behind the proof of this theorem. Before starting the proof, I would like to introduce a theorem 2, which is useful for us to prove extreme value theorem. The theorem is as shown on the slide. Let S be a subset of real number. If S is sequentially compact, then it has a maximum and a minimum. Now, let's begin the proof of EVT. First, let's assume D be a closed and bounded subset of real number, and f is a continuous function defined on D. To complete the proof, we have to show that the range of f has a minimum value and also a maximum value. Actually, by theorem 2, which I introduced just now, if we can show that the range of f is sequentially compact, then this implies that the range of f will have a maximum value and also a minimum value. So now I would like to show that the range of f is sequentially compact. In order to do so, first we consider a sequence of Yn in range of f. Now we have to show that the sequence of Yn has a subsequence that converges to a point in the range of f. By the definition of range, for all positive integer n, there exists an xn in D such that fxn equal to yn. This gives us a sequence of xn in D. Since D is a closed and bounded subset of real number, D is therefore sequentially compact. This means that there exists a subsequence of xnk of sequence f of xn such that the subsequence of xnk converges to L, where L is a point in D. Next, we use the same index to define a subsequence of Ynk of sequence of Yn. Since f is continuous, we can make a limit of a function become function of a limit. Therefore, this results in the subsequence of Ynk converges to Fl as shown as the slide. Since L is in D, Fl is therefore in the range of f. Thus, we have shown that the subsequence of Ynk of a sequence of Yn converges to a point in the range of f. This implies range of f is sequentially compact. So, by theorem 2, range of f will contain a maximum and a minimum. Therefore, our proof of EBT is complete. Next, I would like to briefly talk about the importance of EBT. Extreme value theorem is vital as it has several practical and theoretical implications in various fields, including mathematics, economics, physics, engineering, and computer science. For example, in calculus or mathematical analysis, due to EBT guarantee the existence of both maximum and minimum value for a continuous function on a closed and bounded interval, it is useful in proving many kinds of vital theorems such as row theorem and Darboux theorem. Besides, in computer science and algorithms designed to find optimal solution often rely on EBT to ensure the existence of solution in the search space. In economics, the extreme value theorem is relevant in areas such as utility theory, where economists analyze consumers' preference and choice to maximize utility or profit. EBT provides a basis for establishing the existence of optimal choice in economic model. In short, extreme value theorem is really a very useful and important theorem since it is well applied in various fields. Next, I am going to enter the last section of my presentation, which is discussing an example of how the continuous function is used. I would like to give an example of application of concept of continuous function in aerospace engineering. On April 24, 1990, the Hubble Space Telescope was deployed by the Space Shuttle Discovery. A model for the acceleration of the shuttle during this mission from liftoff at t equal to 0 seconds until the solid rocket boosters were jettisoned at t equal to 126 seconds is as shown on the slide. That is, AT is equal to 0.003906 t squared minus 0.18058 t plus 23.61. Now the problem is, the aerospace engineers in NASA want to estimate the absolute maximum and minimum value of the acceleration of the shuttle between liftoff and the jettisoning of the boosters. Before they find the absolute maximum and minimum value of the acceleration of the shuttle, they have to determine that whether there exists a maximum and minimum value of the acceleration. From the information, we know that the shuttle lifted off at t equal to 0 seconds and the booster were jettisoned at t equal to 126 seconds. So the time interval for the acceleration function should be closed interval of 0 to 126. Thus, the domain of the acceleration function will be closed and bounded subset of real number. Now, since the domain is closed and bounded, if we can determine that the acceleration function is continuous, we can easily apply extreme value theorem to conclude that there exists a maximum and minimum acceleration value. Obviously, the acceleration function is continuous since it is a polynomial function of t. Therefore, by extreme value theorem, the aerospace engineer can conclude that there is a maximum value and a minimum value for the acceleration of the shuttle. And after undergoing some calculation using knowledge of calculus, they find out that the maximum acceleration is about 72.87 feet per second square, and the minimum acceleration is about 21.52 feet per second square. In short, concept of continuous function is very vital in this astronautic situation because by determining that the acceleration function is continuous, the aerospace engineer in NASA is able to use an easy approach, which is extreme value theorem, to ensure the existence of maximum and minimum acceleration value of the shuttle. And this is all for me today for my presentation. Thank you for spending your time to listen to my talk, and I wish you have a nice day. Bye bye.